All right, let's do some data. Well, we're going to see what data analysis really looks like in the wild. So, a quick reminder that if you want to find out more, you can head over to dataindependent.com, and we have a ton of different pandas functions. We have more videos, we have code samples, we have explanations, we have all that good stuff. So let's jump into it. So what I want to do today is I want to do something with the San Francisco data set. And San Francisco has a really nice open data set, datasf.org, fabulous. And what I want to do today is I saw a street cleaning data set, and it looked like a good mix of string parsing, some locations. We can do some plots and do some just general data analysis. And so we can see what we have here. So first thing I'm going to do is we're on the dataset website here. I know it's under city infrastructure. And then I searched by most relevant, and I saw one that said street cleaning. So let's find out where the street cleaning one is. Street acceptance. Might have to do a search for it if I can't find it. Street cleaning sweeping schedule. Perfect. So there's that one. I'm going to click on this. I'm going to let that pop up for me. And then I am going to export. Now, very important. Some people like to export for Excel because they think it's safe. Just always do CSV. That's what Pandas and Python is going to be able to read easily. So there's our file right there. What I'm going to do is I'm going to show this in the Finder. I'm going to copy. It's going to put it right on my desktop. Now I'm going to put it, I'm going to copy. I'm going to put it right in my Scratch folder. Great. Cool. The next thing I'm going to do is I'm going to open up an Ipython notebook, and let's take a look at what we have. So in order to do that, I'm going to go on my desktop. I'm going to go to my data independent folder, going to go to my Scratch folder where I put my file. And I'm going to ls to make sure that I have it. There it is, street sweeping schedule. So I'm going to say Jupyter Notebook. Great. So now that I have my Jupyter Notebook, let's go ahead and let's create a new Python folder or a new Python file. And I'm going to call this street sweeping exploration. Great. And of course, we're going to start, as always, as import pandas as PD. And what I'm going to do here is I'm first going to import the data, and then let's take a look at it and then make a plan to see what we want to do. So to start it off, I'll say df equals pd dot read CSV, and this is street sweeping schedule. So I'm just typing out the first 4 characters, and then I click tab, and it will autocomplete for me. And so I see my CSV right there. Great. And so I loaded it up, looks good, and I'll call df head so I can see what the heck we got going on. So we have CNN, which we can go back to our data set, and it'll give us the explanation about what it is. So centerline network number, unique identifier for every street segment. It's kind of interesting. I don't know if we're going to use that. So corridor street name from 2 streets, and we can show all here. So it looks like full name of weekday and abbreviated week of month service. Okay. Weekday from hour to hour. Great. Week 1. So serviced on the first week of the month, second, third, fifth. Looks like these are almost like dummy variables. Holidays, swept on holidays. Great. And then block sweep ID, unique ID for this data set. Okay. And then represents vector geometry on this map. So that's actually the thing that I wanted to look at. Because you see here it says line string, and then it looks like it has a latitude and longitude. So I think it's going to be pretty cool to plot these out, and then maybe color code based off of the day of the week that it is street swept. And we can take a look at it and see what the heck is going on. So first, let's see. Let's do some exploratory data analysis, EDA, and I'll start off with just quickly describe. Actually, no, I'll do I like info better, because then I'll see the columns and I'll see how many data points we have. So we have 38,000 data points. Looks like we have a couple nulls in our block side, and everything else looks pretty good to go. Yeah, it looks good. So the next thing I want to see is I want to see the weekday. So I'm going to do a value counts on weekday. And so let me keep the dot head right there. But let's do a df weekday dot value counts. And so this will tell us how many rows have this label in it. So it looks like Monday is by far the highest day that's street swept, and it looks like holidays. So I wonder if these holidays they're only swept on holidays, or holidays are included. So this is weekday. So what I'm going to do here is I see that there's 824 rows that have the holiday label, but I also know that there's a block sweep ID right here. So I want to see, are there 824 block sweep IDs, or are there multiple rows per block sweep ID? And I guess the easy way to do that is what I'm going to do is I'm going to say df block sweep ID, and then I want to see is there only one row per unique block sweep ID. So I will do value counts, and then here I get a bunch of ones, and then you could see that by default it sorts it, and the top one only has one. So yes, so it looks like these are only swept on holidays. Okay, cool. Makes sense to me. And so let's take a look at the full name and let's see what options we have right there. We have a bunch. So it looks like actually Wednesday is the most unique full name, and then the days of the week, and then we go into the Monday, second and fourth week of the year, or of the month, and then we have like a first Friday. Well, first Fridays would be the least. Okay, makes sense. And then let's take a look at the most common 2-hour from hour situation. So the way I'm going to do that is I want to say, let's do from hour, and we're going to pull out 2 columns, 2 hour. So we have all these from hour, 2 hour. I forget, can we do a value counts, right? Yeah, we can, which is nice. So it looks like the value counts for these 2 combinations. Looks like 2 to 6 is the most common hour. 6 to 8 is the next most common hour. And then 12 to 4, so that's 12 p.m. to 2 p.m. Great. And then 0, which is midnight to 6. Cool. Great. So I'm going to do I'm going to make a derived column, and the derived column I want is like duration. So like sweep duration. So the way I'm going to do that, I'm just going to say sweep duration, and I'm going to say, and that is going to be 2 hour. Actually, let me see if any crossover the midnight time. So we have 8 to 9, 10 to 50. Yeah, so here's one. No, that's not one. So I'd want a big number to a small number, and I don't see any that cross over, which is a good thing, because I'm just seeing if we're going to get some funky, when we do subtraction, if we're going to get anything funky. So 2 to 6, nope. So this would have to be a big number, nope. Like 20 something, nope, we look okay. So 2 hour. From this time. Okay, so we got that. Let me make sure that it looks good. Let me reload the df head, and we'll see duration. So 3, confirm that it's from 12 to 15. Makes sense. Great. All right, so we have those, and because this is like just doing some feature cleaning up, I'm going to put that right underneath where I load my data. So what that'll do is basically once I load my data, it'll just automatically run this thing, run that feature. And then we got our sweep duration right there. Great. So let's take a look at how often our sweep duration is. Duration dot value counts. Cool. So by far, it looks like the most, like freaking 25,000 of them. I wonder if we can do relative. Yeah, normalize. So let's see what percent. So we have our exact counts of our how many times the row appears right here, but I don't see the normalized because I don't see what percent of rows. So it looks like 66%, almost 67% of all street sweep cleans are 2 hours. Okay, makes sense. And then we have our corridors. So this looks like it. So let's see what corridor is, because I'm forgetting what it is. So corridor, street name. Okay, so what's the limits? limits from streets to streets. Okay, so it's like, what is the street that you're doing? And then what are the from limits to limits? So let's look at one example here. So I just want to see what this looks like on a map. So it looks like Palace Place, San Francisco. Great. So, yep, there it is. Palace Place street sweep. And it looks like it's from Crest Lake to Sloat. And here's Crest Lake and here's Sloat. Makes sense. Let's see if we can do a street view and see the actual street sweep line. Street sweeping there, and there looks like there's one right there. Look at that. All right, let's see what it says here. 9 to 11, second and fourth Tuesday. All right, so this one says first, third, and fifth Monday. This could be on the other side. And so let's pull out all the street sweeps on this street and see if there's multiple, how many street sweeps there are. So what I'm going to do is I'm going to say corridor, I'm going to say equals, and I'm going to say Palace Place, and then I'm going to wrap that in my DF to get the filter. And good, so I have two of them here. And here it is. On the right, looks like it's on the right-hand side. The block side is on the west, and second and fourth Tuesday. Second and fourth Tuesday, 9 to 11. And we have 9 to 11 right there. Then let's triple check that this is the west side. You can see our little guy down here. He's pointing towards the west. And the way I know that is the Pacific Ocean is on this side. So, yep, that makes sense. Let's look at the other side. There it is. So it looks like second and fourth Friday from 9 to 11. Maybe this is new data. Maybe it's switched, but I'm glad one of them matched. I'll just triple check over here. Yep, still says Friday, so maybe it's switched. Who knows? Cool. So, yep, that looks like it's good to me. And then we could see what are the most common weeks that are the most common week combinations. I'm assuming that because we did full name value counts, and you could see that all these, like, it doesn't specify which week of the month it is. I'm guessing that it's going to be all weeks is going to be the most popular one. But let's do this. Let's create a list, and then there's definitely faster ways to do this, but I'm just going to do it this way. And then, in fact, maybe I'll show you one more. I think that we can do the find, and that'll be a lot easier for us. But let's do value counts. So you can see here that all 5 weeks, there's 23,000 that are done every single week. But yep, that makes sense. So there's also DF find. No, not DF find. Column like pandas. Partial string from pandas data frame. String dot contains. No. It's funny. I just did a tutorial on this, I'm pretty sure. And I'm already. Oh, I think it might be where. No. Pandas column like. No, query. Yeah, that's it. I'm pretty sure. Query the columns of a data frame with a Boolean expression. Yep. In fact, I'm just going to go to data independent query. Let me see if I pop up on Google yet. Doesn't look like it. Dataindependent.com. I did a query one, filter data. Oh boy. Okay. Nope, this is not the one. Column like sort values diff, iloc not merge, hist imax, no, not describe. Shoot, I'm letting you guys down right now. That's okay. So anyway, there is a way where you can say, hey, give me all columns where there's the week. I'm forgetting what it is right now. It's not important. So we have that. All right, let's get to the good stuff. And so what I want to do here is the one task for today is we are going to plot out this lat long on a scatter plot. And then we are going to label the colors based off of the day of the week that it is, that it's done by. So first I want to extract, it looks like we have, if I were to take a look at this df line, capital L, if I were to take this df line, you can see here that we have there's like a bunch of different locations in here. And to be honest, I'm not sure what those different locations mean. I just see represents a vector geometry objects on the map. So maybe what it is it's going to be like a square that it's drawing. But let's take a look at this first example and let's see what we have here just on Google Maps. Can't find, great. Can't find, great. Can't find it, great. That's wonderful. What's here? Oh, so you see here that they have, it looks like they have it's flipped. And so I'm thinking that it might be flipped for us. Great, so there's that. All right, so there's that section right there. Let's see what this first one represents. So it's Sparta and it's Anki and Kenny to Harkness. And so here's Ann Kenny, there's Sparta, there's Harkness. This looks like it's the Latin long, so that's good. So I want to extract the first Latin long from this string right here. But you can see it's a bit of a mess, which is why I picked this, because that's going to be good for us. And so let's do, let's pull out the first one just to see what we got here. Okay, so we have the first one, and you can see here it's a big box. So well, we have 3 of them, so maybe it's a triangle, but whatever. I just want to take the first one because that's easy. And what I want to do is I'm going to create a function that will extract this information for me pretty cleanly. And so the way I'm going to do that is I'm going to create I'm going to create a custom function up here and call it extract first lat long. And then what you're going to do is it's going to be messy string. And this is going to be our messy string right here. So in order to make sure that works, let me just first print messy string. And then what I'm going to do here is I'm going to extract this. And I'm going to say first Latin long, and there's my first messy string extracted. And so the next thing I'm going to do is it looks like every single line starts with line string. So the way I'm going to check to do that is I'm going to say dot contains, and then I'm going to say line string. And you can see here that if it contains line string, then it's all true. And what I want to do is I see that there's 13,815 observations. And so I'm going to say sum, and it looks like 7793. So not all of them contain line strings, which is kind of interesting. So I want to see the ones that don't contain line strings. And the way I'm going to do that is, so if these are all trues, what I want to do is I want to wrap this in a df, but it looks like there's NA values. So that is the problem. So I'm going to go up here and let me triple check that there's, so df.info, and looks like we have line, and yeah, there are some missing ones. So I'm going to say just fill these with, it's a good practice to fill NA, fill NA, and with just a blank line, I'm going to say in place equals true. Great. So now when I do my, you can see here that now we filled up all those, which is good. Okay. So now that I have this, so there's a line string, and then let's look at the ones that do not contain. And so I just put a negative in front of there. And so I'm gonna just do a dot head, and we could see what these look like. And you go over here, it's just blank. So that's what it is. And, you know, for this purpose, I'm not trying to be exact. And so I'm just going to take the blank ones. Great. All right. So now that we have, so let's take a count for those blank ones. And so if messy string equals blank, then just do nothing, then return, we just wanted a Latin long, so we'll just return nothing. So that takes care of that empty account, or empty. And then now we need to extract this thing. And so let's do, let's first get rid of the line string. And so I'm just going to remove line string. And the way I'm going to remove it is I'm just going to say, there's a couple ways. You could say drop substring from string Python from a set of strings. And it looks like you can just do dot replace with nothing. And so we'll just do that. And so we'll say we'll say new string equals messy string dot replace, and then what we want to replace is line string space. We want to replace that with nothing, and then let's print this out to make sure we're good. Yep, we got rid of that, which is good, and there's no space in front of there. So now this is a big fat tuple, and so, but that's tough because then the numbers, well, I guess I'll be kind of messy about this, but we'll just get this done the fast way. So I want to see how many characters this is. Then I want to extract those characters from, I want to extract that substring. So we can see it's 33 characters. And so let's just say, for example, I wanted to print out, I want to skip this first one, but then I want to go forward 33. So the way I'm going to do that is I'm going to say 1, and I'm going to say 34, and I'm just going to see if that works. And what do you know? It is really nice right there. So let me make sure that this works for a couple different strings. And so I'm going to say dot apply, and I'm going to do a lambda function because what's going to do is it's going to iterate through the different instances of line for this range. I'm going to say just like the first couple, and then I want to say extract first one. I'm going to pass x. So it says none, 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 but here this is good because it printed out. It looks like it printed out all the lines that we wanted, which is nice. Cool. So I'm going to say new string equals new string. And so now we have that. And so I'm going to make sure that still works just because we're being iterative. Great. And we still have that. So now I want to extract the Latin long. And the way I'm going to do that is I'm going to split by a space. And I'm going to see if that works. And so what I will do is I will take this, just copy it, and because I know it's a string, I'm going to put that down there, and I'm going to say split, and I'm going to say by that. Good. So what we get is, you see we split, and what that means is basically just split up your string and do a list, and I split it by a space, and it cut up it cut up the different instances here. You can see here that these are strings, and so we'll need to convert those into ints, or not ints, but floats, but that's okay. So lat long equals new string, and I'll just pretty much copy what I had right here. So new string dot split. Great, and let's return this Latin long for us. Great, and so you can see here we extracted those. And so let's see, and remember that I wanted to put these in opposite order because I wanted this 37 first, and then I wanted. So let's see, reverse order of list Python. Slicing trick to create a reverse copy. Okay. So let's see if that works. Yep. And then what do you know? It reversed it for us, which is good. So this looks like how you reverse it. Awesome. And then let me convert these. Convert list elements to float. And it looks like float for list and I. Great. So what we're going to do here is we're going to do a little list comprehension, and we're going to say lat long equals float for I in LST. And now we have our floats right here, which is good. Beautiful. So now what I want to do is I want to actually turn this into 2 different columns. So the way that I want to do this, well, I tell you what, let's just return 2 values. So what I'm going to do here is I'm going to return lat, first of all, I'm going to say lat long equals lat 0, because that'll take the first element, meaning it'll give us 37. And I'm going to say lat long 1. And then what I want to do is I want to return lat and I want to return long. So let me do that. And then you can see here we get our tuple, which is good. Okay. So great. So then what I'm going to do is I'm going to say df lat equals this, and we're applying the first one. But because I want to, let me see if I can do this. No. So I'm going to just say, give it this one. I'm going to, all right, so there's our first expression, or our first one. I'm going to pull out the 0. Yep, and there it is. And so what I'm going to do here is I'm going to say, give me that 0. Let me see if we can just do 2 of them. I don't know if pandas can do this, but we'll see if we can assign 2 columns at a time. If it can't, we'll just do it the long way. Nope. Oops, so no, we want to just do everything. No, cannot convert string to float. Fabulous. It looks like we ran into a problem because one of our things wasn't long enough. So that's great. So we're going to have to, it's not great, but we just need to debug that. And let's see if we can find out what row this is. And so we can, no. Can't find out what row it is. And so what I want to do here is, well, the reason why we get ourselves in trouble is because this 1 through 34. And because we removed everything, but we just want to take the first element. So what I'm going to do here is I'm going to again just go back to my testing mode. And testing mode means just do the first couple elements. And so I'm going to go 0 through 3, apply, great. And what I want to do here is I want to print new string. Great, so we have this new string. And so what I think that I'll do first is I'm just going to split by this and then take the first element instead. So if I were to do that and I were to say split, I'm going to say split comma space, then you can see here that we get our first element, and it still has this little garbage in front, but we'll get rid of that. And so I want to take the first one. There's that. And then I want to take, this is getting kind of messy here, but I want to take everything after the first one. And so I'm going to say like that. And then you can see here we get that string that we wanted beforehand. Great. And so I'm going to say new string equals this. New string equals that. So let's see if we can undo this. Great. And so we still get our lat longs, which is wonderful. And let's see if this converts. Let's hope. Too many values to unpack. Okay, that's fine. I think it's because this is not efficient because I'm running it twice. Okay. Great. Okay, what I'm going to do here is I'm going to go back to my testing mode. This works. Let's see if we can pull out the first one. And that still works. So that's kind of weird that it was giving me a hard time. And it says it's out of range. Okay, that's wonderful. And so I wonder if it's out of range because, so I'm going to say print, I don't want to say print messy string because that's, actually, sure. Let's just see what this does. And so we can see which one we got the error on. So in this case, it looks like we got the error on this one. And so I want to, what I want to do is I want to take this exact string that gave me the hard time, and I want to see if it's going to give me a hard time right here. And it doesn't give me a hard time. Okay, so then it must have to do with just the first element. All right, so let's see if we can do return lat and long. And do we give us a hard time? Yep, string index out of range. So I'm going to try pulling it out. Okay, this is fine, whatever. What I'm going to do here is I'm going to do this another way, and I'm going to make sure that this works. And it's gone through everybody. And you can see it here. I printed the messy string, which is why it's giving me a hard time. It's printing so much. And then good. So we have all this. So what I'm just going to say is df lat long equals the line. Great. So df head. Beautiful. And here we have our lat long, which if we checked the type of this, let's do ilock 0. And then let's do lat long. So we can get our first little element here, and then I'll check the type of this. You'll see that this is a tuple. Great. So what I want to do here is I want to say split tuple column pandas. Great. And so it looks like the way we want to do this is toList. And it looks like toList. And you could just call out the different columns there. I'm looking at this example right here, where you call it two new columns, and you just say what you wanted to list, but it looks like you may have to wrap it in a data frame. So we'll see what we got to do here. So let's go df lat long, and we'll say to list. We have our list there. Great. And let's say pd data frame. Cool. Then we have our two lat and longs right there. And then we'll say df lat and then comma long equals this new thing. See if that works for us. Great. Df head. Great. And there we go. There's our lat and long finally extracted from there. Okay. So wonderful. So I'm going to take this and I'm going to put that right down here. And because this is really a feature engineering thing again, I like to put the feature engineerings right up in my imports. And so I'm going to import it. I'm going to do the sweep duration. I'm going to do the line. I've defined a function here, and then I do my lat and longs. So I'll run that, and then all of a sudden, every time I run this data set again in the future, I have it ready for me. There's lat and long. So let's get to the real juicy part of this. I want to create a scatter plot, and you could do this a couple ways. The way that I like it best is probably, you could do matplotlib or data frame plot. Let's do df plot. Actually, let's do matplotlib because that one's a bit easier. It gives you a bit more functionality. So I'm going to import matplotlib.pyplot as plt. Great. And then I'm going to say plt.scatter. And then now I need to give it an x, a y, a size, and a color. And so x in this case is going to be df, and then I'm going to say lat. Df lat, and let's make sure that this works. And then y equals df long. Fabulous. So here we get a kind of gross looking thing of San Francisco, and I can tell, well, let me make the size of the dots smaller so that we can start to see some things. And there's 5, and let me do, 2. And I can tell that I want to get this bigger in the first place. So plt.figure and then fig size equals, I always forget which one goes first. I think it's width and then height. So I'll do 8 and then 12. Yeah, I wanted it longer than I wanted it. So I wanted to change this to 12 and 8. Great. But that's a little bit too big. So let's do 8 and 6. Great. And I can see Golden Gate Parkers right there. So actually it looks like I may have my lat and long switched. So, so I could either switch it all the way up here, but because, it's really not that big a deal and I just want to show you guys, I'm just going to switch my X and my Y's. Let's see if that works for us here. It looks good, but it looks flipped. It looks inverted. And so the way that I've seen other people do this is they can do their X limbs. And so they actually switch their X limbs. And so it flips their plot around. So X lim is going to be the X limit. And so here you can see it's 122.52 and then 12238. So I actually want to do that 122.52 and then 12238 first, And so this will flip it around, because now I tell Panda or Python, hey, I want you to do this one first and then go over to 338. So that's a kind of a poor man's way to do it. I also want to fix my Y limits because I got way too much padding up here. And it looks like we go from 370, so 37.7, and we go up to 37.8, so 37.82. Let's try that and see how that looks. It looks like that is way off, so I messed something up. All right, so we're at 37.7, and then we're at 37.82. 70. Oh, that's because I switched it to the XLim. Whoops. YLim. Cool. Looks good to me. I'm gonna extend this other XLim out just a little bit, maybe just a little bit more. Great. And so now we have that. Cool. So what I want to do here is I want to color code these based off of the day of the week that they get swept. So remember that the day of the week is on weekday. So to prove it to you again, I'll do a df weekday dot value counts. And you can see here I only have, I have all these different options. So the quickest way to do this, I mean, there's a million ways you could do this. The way that I want to do it is just via a dictionary. And so I'm going to say, and this will be really just kind of crude, but color dict equals, and then I'll get rid of this stuff. And then we're going to do a key value pair. And then what we're going to do is based off of the week of the day, we're going to do this. And here, because matplotlib, you can just do some easy colors. If you wanted a full list, you could go to the matplotlib documentation and see what you got. And so we'll close that. And we'll say blue, we'll say green, we'll say black, we'll say yellow, we'll say, well, let's go matplotlib colors. All right, so we have magenta, which would be an interesting one. And we also have, I don't want to do white, we have cyan. I guess we'll do that one. I even forget what color cyan is. Looks like it's going to be a bluish. Great. Cool. So now we have our color. Now we have our color dict, which is good. Fabulous. And so I'm going to go up here because, again, this is kind of like a feature engineering thing and it's never going to change. I'm just going to put the color dict up there. And it says that, okay, perfect. So we have our color dict. And now I'm going to say color code this. I'm going to say color code this based off of the day of the week. And so this color, which is C, equals df, and then we're going to call it the weekday, and I want to put this in the color dict and see what comes out. So color dict, and then the key that is going to be this weekday. And so let's see if I can pull this out and show you what this looks like in the first place. Cannot be hashed. That is fine. Cannot be hashed. Oh, my bad. So what we want to do here is we actually want to do a lambda function again. So we're going to do apply. And so we want to iterate through all the elements, lambda x, and then color dict x. And we didn't put a holiday one. Whoops. So we got to put an extra one for holiday. And let's make this one. Let's see what other colors do we have. Yellow, black. Which one didn't I do? 1, 2, 3, 4, 5, 6, 7, 8. I guess I didn't do white, but let's just do a random color palette generator. One of my favorite ones is this Coolers one. They do a really nice job. So you can just go and this is where if I ever need to pick a color palette, I'll do it. I'll just do this kind of like fall orange, and I will do hex. So I'll just pull out this hex color, and I hope that I can just do this. Cool. Yeah, so you can see here we get a list of colors that are going to be input right here. So I'm going to take this, I'm going to put this into our color and go apply. It says cannot deal with it. I think it's because my C argument must be a sequence of colors, not yellow. Okay. So it looks like I need to do R, B, G, B, yellow. I wonder what black is though. So map plot lib colors, go back there. Black is K. So K, yellow, M, C. Let's see if that works for us. Nope. C must be an MPL colors, not a sequence of numbers, not Y. Okay. So let's just make this one K too. And if that gives us a hard time. Cool. Nice. There we go. Looks like we can't mix color types in there. So here we go. So now you get the different, like what day of the week's street cleans are. So let me type in color dict here to remind us what we have. And let me zoom in. And the way I'm going to zoom in is I'm going to say 8, 12, 8. I'm going to do it. And let's make these sizes just a little bit bigger because to fill in a little bit more color for us. Great. Beautiful. So it looks like I'm seeing some alternating blacks and reds. And so remember, it's Thursdays and Mondays. Alternatings right near the park here. It looks like there's a kind of a connection there and some blues. It's kind of interesting to see the different neighborhoods and then how they have different street sweeping schedules. Like here's black and blue all over. There's some reds. Yeah, interesting. Cool. So last thing that we'll do is we'll put a title on this guy and we'll say street sweeping schedule SF San Francisco in the title. And if you pro tip, if you want to get rid of this like extra thing, just put a colon at the end of your last plot statement and it'll go away. And there you go. So that's how we make a scatter plot. We did a bunch of funky different pandas things in there, some string parsing, and yeah,